grab your sun hat, some sturdy boots, and a good supply of water. And if you happen to find yourself in East Africa, just ask for Lucy. Welcome to the Backpacker's Guide to Prehistory. Hello and welcome to the Backpacker's Guide to Prehistory, the podcast that provides top travel tips for time travellers. I'm your tour guide, David Mountain. Saddle up, because in this episode we're riding across the plains of the Neogene. Beginning 23 million years ago and ending just 2.5 million years ago, the Neogene is one of the most recent periods in prehistory. It's made up of two subdivisions, the Miocene, which takes up almost 90% of the period, and then, squeezed in at the end almost like an afterthought, the Pliocene, occupying just the last 3 million years of the Neogene. As a result of its proximity to the present day, the Neogene is a strange time for backpackers to visit, at once familiar and bizarre. It sits in prehistory's uncanny valley. You'll be walking along and see plants and animals that you might encounter today. But then you get a bit closer and you see things that just aren't quite right. Emerging from a burrow, you see a rodent with horns. Over there is a giant flesh-eating bird. And crashing through the forest behind you is an elephant with 4 tusks. Needless to say, all of this makes the Neogene one of the most memorable time periods you can visit. And to guide me through the curious world of the Neogene, I've enlisted the help of 2 experts. Dr. Ali Baumgartner, a paleobotanist at the Sternberg Museum of Natural History.
Hello!
And Dr. Laurence de Mouchel, a paleoanthropologist at Wichita State University.
Hi!
So, Ali, to get started, can you give me an overview of the Earth during the Neogene? What was it like? What was the climate like?
So the Neogene is obviously my favorite time period. And while I often like to joke that working in the Neogene is doing paleontology on easy mode, there are still some very interesting differences. So one of the reasons it's so interesting is because when you're in the Neogene, most of the continents are in the arrangement that we would expect today. So North America, South America, Eurasia, Africa, most continents are where you would expect. But that is a major change from what we saw earlier in the Cenozoic, coming out of the Cretaceous. So these changes in the orientation of the continents are doing major things to ocean currents. So, for example, the connection of North and South America completely changes the way that the ocean currents are moving in both the Atlantic and the Pacific. The Bering Land Bridge opens up during the Neogene. Before that, you had basically a continuous connection across most of the Northern Hemisphere. So you have currents moving, different parts of the world are getting different temperatures, but also you see this overall cooling trend, and that's the major thing. So if you look at the Cretaceous is a greenhouse world. It is a hot time. And then as you go through the Cenozoic, it gets cooler and cooler and cooler until you hit an ice age. So the Neogene is basically that transition point from that kind of hot house Earth into the cool house into ice house. So basically, the continents are where you would expect. The temperature is almost what you would expect. And if you're a time traveler, like Neogene is easy mode. Start there.
That's nice to know, because a lot of these trips are, to be honest, hard work. You have to do a lot of planning.
Right.
And that actually takes me to my next question, which is, what should I pack for this trip? What's the weather going to be like on a typical Neogene day? Or does it depend on where in the world I go?
Right. So, like I said, easy mode. The overall temperatures of the Neogene are higher than today. By the time you get to the end of the Pliocene, it's actually not that much higher than today. So you're going to want to probably, a little bit lighter than you would necessarily pack for camping now, hiking now. But there are a couple of things that you need to consider. Because temperatures were higher, that also means that precipitation is higher. So you're going to have higher temperatures and it's going to be wetter. Also, we see a whole lot of variation and variability in climate during this time. So it could be super variable. So obviously, layers. Make sure you got your warm layers, you got your cool layers, something to keep you dry in case we have a surprise drizzle. But honestly, probably not that difficult to pack for.
Okay, fantastic. Now it's getting colder, like you say, and it's not too dissimilar from the world we know today. So I'm assuming, quite unusually for these trips, there might be some snow and ice to contend with, depending on where I go.
Yes, so depending on where you go, throughout the Neogene, you're going to have continental ice on Antarctica. So basically, you're gonna have to probably do very similar things that you'd have to do now if you tried to go there. Throughout most of the Neogene, there actually wasn't considerable sea ice in the North Atlantic or the Arctic. We don't really see considerable sea ice in the Arctic until close to the end of the Pliocene. And then we begin to see, again, a world that looks very similar to today with permanent ice in the Antarctic and sea ice in the Arctic. But even outside of that, you're probably actually going to have at least some snow in some places. Again, because it is a higher average temperature, you're not going to see as much snow in maybe all of the places you would expect. You're going to need to go to greater extremes. So, higher latitudes, higher elevation, that sort of thing. But you would definitely find some snow, at least in some parts of the world.
That's nice. I'm a big snow fan, and living in the UK, you don't really get much of it. So it's nice to know that it's there if I want it.
Yes, but only if you want it. You don't have to experience it if you don't want to.
Okay. Now, one of the defining features of the Neogene, along with this cooling, drying climate, is the spread of grasslands. To start off here, it's probably worth mentioning just how diverse and abundant grasses are, because it's much more than just lawns and golf courses, isn't it?
Oh, yes. It's kind of sad that that is what grasses have been relegated to because they are the, I think, fifth largest family of flowering plants. So they are very large. There's approximately 780 different genera, about 12,000 species. Today, they're found on every continent except Antarctica, which is pretty standard. But yeah, they're very abundant. And so the fact that when we think of grasses, we think of, yeah, lawns and golf courses, there's so much more than that. So in addition to turf grasses like that, you also have cereal grasses. So those are the ones that we eat. And it's basically almost every major grain that we've domesticated is a grass. So maize and rice and barley and wheat and millet and all of those things are different types of grasses. So most people's diet really does have a considerable amount of grass in it. And then in addition to the things that we walk on and the things that we eat, I live in Kansas, which is a grassland. It is a prairie. There are many other types of grasses here. So turf grasses have very small root systems. That's why you can like put down sod, just put it in a layer and you're good to go. But grasses like we have out here in the prairie will have considerable root systems that could be a meter, 2 meters deep easily. They don't mess around. And then in addition, there are other types of grasses that people are probably familiar with. Bamboo is a grass, sugarcane is a grass, reeds are grasses. Grasses, like, if you're envisioning an environment in your head, there's probably grasses in it somewhere.
So, in the Neogene, when we see these grasslands really spreading, whereabouts in the world is it that they're able to take advantage of these shifting climates?
So, when we think of grasslands in the Miocene and today, we tend to associate them with continental interiors. So, the Great Plains of North America, you'll also find them in South America, the steppe across Eurasia, the savannas in Africa, and the not desert parts of the interior of Australia. So, basically, again, with the exception of Antarctica, every continent has some grasslands in some places. And again, that continental interior is really the key because that's the part that's the farthest from the water and is therefore the driest.
Okay, so it's as the planet gets drier, these grasses can expand in places where there's no longer enough water to support the trees.
Exactly. And I was just going to say that there is a relationship. I kind of mentioned it before. There is a relationship between temperature and precipitation. The higher the temperature, the higher the precipitation. We see this overall cooling trend throughout the Neogene, which means that we're also going to see an overall drying trend throughout the Neogene.
Why was it that grasses were the ones to take advantage of this? I mean, what adaptations or advantages do grasses have that allow them to do well in dry conditions?
So, a couple of things. So, the one that most people, if they know anything about grasslands and grasses, are probably already thinking it's C4 photosynthesis. So, very quick crash course in what photosynthesis is. Basically, plants don't eat, they eat light. So, they take water from the environment, they use their leaves to bring in CO2, and by combining those things, they can make energy. And that's important. You have the water and the CO2. And because plants are just opening up their leaves to let in the CO2, if it is too dry, the water will escape faster than the plant can bring in CO2. And that is the basis of all of this problem. And so, in order to counteract that, plants evolved another type of photosynthesis, the C4 photosynthesis. And what this does is basically adds another layer. So instead of just, letting the water and the light and everybody just mix together in the leaf, they're going to separate the steps of the process so that extra water doesn't escape. And that means that the process takes more energy because there are more steps now, but it is much more water efficient. They have a much higher water use efficiency and they lose less water because of this process. So C4 photosynthesis is really a revolution in photosynthesis because leading up to the Middle Miocene, there were C3 grasses. C3 photosynthesis is the type of photosynthesis that, say, trees do. Grasses were all over, but they were C3 grasses. It wasn't until you had this change into C4 photosynthesis that allowed them to really take advantage of these drying continental interior environments. And also, I mentioned they have really, really, really deep root systems. That also allows them to reach a very deep water table and kind of suck up any possible water that may be in the environment.
So grasses didn't evolve in the Neogene, did they?
Correct. They've been around since at least the Cretaceous.
So what were they doing?
They were hiding, honestly. So before that, before the Miocene, all of the grasses were C3 grasses. So they were honestly kind of chilling with the trees. So they still need a lot of light. That's one of the things about grasses is they do need a lot of light because of the way that they grow, but they would be found in these more open environments. So like a woodland, you would have kind of patches of grass as opposed to grass as far as the eye can see, but they were there. They were a not insubstantial part of the environment. And in some places, even in the Paleogene, there were grass dominated environments, but they were C3 grass dominated environments. And they weren't nearly as expansive as the spread of the grasslands that we saw in the Miocene.
Now, grasslands are amazing. There's a majesty to the savannas, to the prairies. But if I'm travelling to the Neogene and I want to see something other than grass, what other habitats would you recommend I visit?
Don't worry, you've got options. If you don't want to see grasslands, you've got other options. Like I said, this is time travel in easy mode. So basically anything that you want to see today, you can see in the Neogene. It might be in a different place, but it's going to still be pretty recognizable. So I've done research on this in multiple different continents. So for example, if you were to go to East Tennessee during the Pliocene, so the end of the Neogene, and just wander around in the forest, it would look virtually identical to the forest in the region today. At least the genera of plants, the genera of trees are basically the same things that you see today. And the same thing if you were to go to, say, tropical Africa, sub-Saharan Africa, you would have extensive tropical rainforests, in addition to tropical seasonal forests and eventually grasslands. in many ways, it is the same sort of environment that you would see today. You have these patchworks of different environments across the world. So any environment you want to see today, you would be able to see it somewhere during the Neogene.
On a practical note, I'm just wondering if there might be certain plants that could be dangerous for backpackers. Maybe they sting, or they're poisonous, or they're spiny or thorny. Is there any way of knowing if plants like this existed in the Neogene?
Okay, that's a good question. So, there are a couple different ways that we could know this. Because that's the nice thing about the Neogene is it is close enough, it's still old, but it's still close enough that we have some options available to us that aren't necessarily available to us if we're looking back in, say, the Cretaceous even. Like isotopic markers or even possibly genetic markers. The thing about plant fossils, though, that a lot of people don't realize is that one, they're far more common than people think. And two, you can get much higher detail than people would ever expect, surface detail. So it'd be entirely possible and likely probable to find things such as in the family Urticaceae, which are the stinging nettles, under some types of preservation, you would probably be able to actually see the stingers of the nettles. And even before people, there were mammals, there were animals that were chewing on these plants and upsetting them. So it is very likely that we would, even if we don't necessarily have the evidence for it, I don't think it would be unreasonable to assume that, like, if you see something that looks like poison ivy in the Neogene, you still probably shouldn't touch it.
Okay, just a bit of common sense when you're time traveling.
Exactly, exactly. Don't eat red berries when you're time traveling. You just don't know. Don't do it.
Not worth the risk.
Exactly.
As Ali said, a map of Neogene Earth is one of the less confusing charts you'll use on your prehistoric backpacking trips. Since the Neogene is such a recent period, and given how slowly the Earth's tectonic plates move, the continents during this time are very close to their current positions. The mountain ranges we're familiar with today, the Andes, the Himalayas, the Alps, they're all there, although they're not quite as high as they are today. Even a number of rivers, such as the Ganges and the Nile, are already in place. There are still some differences, however. There are no Great Lakes in North America yet, as these will be carved out by ice sheets at the end of the Pleistocene period. The Isthmus of Panama, that spindly land bridge connecting North and South America, doesn't form until the very end of the Neogene, meaning that South America is an island continent for much of the period. And if you look to Eastern Europe and Western Asia, you'll find the Paratethys, a vast shallow sea connected to the Mediterranean. As the African plate collides with Europe, the Paratethys is squeezed out of existence. Remnants still exist today as the Black Sea, the Caspian Sea, and the Aral Sea, which is itself drying up. Speaking of vanishing seas, you might want to avoid the Mediterranean on your Neogene adventure. Today its dazzling azure waters make it one of the most popular tourist destinations in the world. But around 6 million years ago the situation was a little different. Around this time a combination of falling sea levels and shifting plate tectonics caused a land bridge to form between Africa and the Iberian Peninsula, plugging the Mediterranean's only connection with the Atlantic Ocean. As a result, the Mediterranean Sea dried up, in an event known by the suitably dramatic name of the Messinian Salinity Crisis. During this time, the Mediterranean basin was a vast, barren salt pan, interspersed with hypersaline pools. So, unless you're into flies and lizards and painful thirst, give it a miss. Having said that, if you visit the Strait of Gibraltar around 5.3 million years ago, you'll witness the even more dramatically named Zanclean Deluge. This was when that plug blocking up the Mediterranean finally gave way, allowing the Atlantic to pour back into the Mediterranean basin at a rate equal to about 1,000 Amazon rivers. It's one of prehistory's most incredible photo opportunities. Just be sure to keep your camera dry. But if these crises and deluges are all a bit too much, you can always head back onto dry land. Laurence, we've heard from Ali how, during the Neogene, the world's continental interiors transformed from forests and woodland into grasslands, whether that's prairies, pampas, savannas, or something else. So I'm interested now to find out what adaptations mammals acquired, both carnivores and herbivores, to make the most of these new open habitats.
Right. It's interesting that you bring in the question both herbivores and carnivores, because there's this kind of feedback system where herbivores learn to run in those open grasslands, and then carnivores do the same. So there's this kind of feedback system where herbivores run away from carnivores, and then carnivores who do better in those new environments are the ones who are able to run fast. And you have your felids and your canids that are going to be especially skilled at doing that. And another great adaptation that occurs with the change of landscape is an adaptation in diet. So herbivores are going to start and eat grasses versus, eating leaves that used to be kind of the most common food source previously. And grass is a little bit more hard to eat than leaves. So the herbivores that are going to be successful are the ones that are going to be built to wear down their tooth crowns. So they're going to have teeth that are harder, teeth that are higher. So they expect their teeth to wear down when they eat. Another type of herbivore that is going to be super successful in those new grassland type of environments are the ruminants. And that is because, right, so not only is grass harder, but it's also less rich in nutrients. So the fact that the ruminants have multiple stomachs is going to be a system that allows them to extract more nutrients out of this new food source versus the ones, that have less stomachs that are not going to get as much out of eating this new food source. So ruminants, we know a lot of them in our modern environments like goats and cows and sheep. We're thinking, if we're thinking about Africa, of course, our antelopes are also a type of ruminant. Other animals that are going to be super successful are going to be horses. They have those super higher tooth crowns, and they're also extremely skilled at running.
Earlier, I described the Neogene as the uncanny valley of prehistory, in the sense that there's a lot of organisms and landscapes that look recognisable to us humans. You've got horses, you've got ruminants, you've got woodlands and grasslands and things like that that feel familiar. But then, every so often, you see something that doesn't quite fit that expected pattern. And one of my favourite groups of animals in this regard are the Calicothias. So I was hoping you could describe this group to me and maybe explain what they're related to, because they look like nothing on Earth today.
Yes, they're definitely weirdos. As you mentioned, David, a lot of the animals start to look more and more similar to animals that we have today versus other periods of prehistory. But yeah, Calicothias are definitely out of the lot in the sense that they look very strange. It might be surprising, but they are most closely related to tapirs, horses, and rhinos. And all three of them belong to a taxonomic order called the Perissodactyla. And they are a type of ungulates, so technically ungulates. You'll see the story with the Calicothias. Technically, they are ungulates, meaning that they have hoops, but perissodactyls, contrary to artiodactyls, which are going to be like your cows or your antelopes, have an uneven number of toes, so 1 or 3 toes per paw. So again, right, horses and rhinos, they don't look all that similar, but they do belong to that same taxonomic order, which also includes your Calicothias. So Calicothias look nothing like, or not very much alike, rhino or a horse. They have extremely long forelimbs. Some people say they look almost like gorillas because they have such elongated forelimbs. And not only that, but they don't have hoofs, they have claws. You would expect, because they are part of the perissodactyls, you would expect them to have hoofs, but they don't. They have what we call secondarily developed claws. So they evolved from an ungulate ancestor, these weird claws. And one other thing that is interesting about their claws is that they're not used, like a lion would use them or felid to attack prey or a competitor. We think they're used to eat. So to bring branches down and to be able to eat those leaves that are higher up in the canopy. So they have this very particular type of physique, this very particular morphology that looks nothing like, what we see today. So if you do travel to the Neogene and see those, make sure to take pictures.
Definitely, yeah. Another remarkable group of animals in the Neogene are the elephants and their relatives, partly because elephants are incredible to look at, but also because this group is much more diverse than it is today. So, are there any particularly impressive species that you recommend I keep an eye out for on my Neogene safari?
Yes, elephants are an interesting group because, as you mentioned, they're much, much more diverse than they are today. A lot of megafauna will eventually go extinct. So animals that were very large in size used to be a lot more common in prehistory, particularly the Neogene, than we have today. And elephants are no exception. We are actually talking about Proboscidean, which is the larger order that includes the modern elephants. And yes, there are some interesting characters in there. There are, of course, your mammoths that we're all used to hearing about. One of my personal favorites is the dinosaurs. They are, you said to watch out for, so that reminded me of that. Their name translates to, I think, terrible beast or something like that. They're not all that bad. They're slightly larger than a modern elephant. They're not all that, terrible, but they are certainly interesting. They have those tusks that, instead of pointing upwards, point downwards. And we're not quite sure what they're used for. Could be, to dig in the ground and look for tubers. There are herbivores, so they're not the scariest animals around.
That's good to know. So, keep your distance, show some respect, and they're probably going to respect you back. All right. We've been talking a lot about herbivores. What about carnivores in the Neogene? What were the main groups at this point in time?
So all the carnivores that we have today are actually closely related to each other, belong to the order Carnivora. So you have, your cats and your dogs and your hyenas and your bears and your smaller carnivores like weasels and raccoons and such, who are all comprised within the order Carnivora. But we have during the Neogene other groups that are clearly meat eating, but are not within that order. So, for example, creodonts, clearly, they have pointy teeth. They're clearly hunting. They look almost like, modern carnivores. And for a long time, paleontologists in the field thought they were ancestors of modern carnivore. But our current understanding is that they're actually more closely related to the modern pangolin, which doesn't look very much like a carnivore, but yeah, apparently that's what it is. And yes, as I mentioned, several of the carnivores that we have today kind of originated or became more common during the Neogene as the environment opened.
One of the big reasons that a lot of tourists go to the Neogene is to see the very first humans as they appear, because it is at this time that the very first members of our family tree, the hominins, start to make their appearance. So, where in the world should I go if I want to catch a glimpse of these early humans?
Yes, that's where I would go for sure. So there's kind of a debate as to what the earliest human is or when they appear. The first one that is confirmed appears 4.2 million years ago in East Africa. So that would be kind of a sure value. If you go to Tanzania, go to Kenya, and you would certainly find them there if you're lucky. But we also have up to 7 million years ago what we call hominin candidates. They could possibly be the earliest hominins, but we don't have enough information at the moment. And these are found in East Africa, but also in Central Africa. So that could also be a possibility. So in Chad, we have some early candidates for early hominins. And just in general, the beginnings of the hominin lineage is in Africa in general. So we also have early hominins, we call those Australopithecus. We also have them in South Africa. So that could also be a possibility.
Now, unlike today, the late Neogene was home to several species of hominins living at the same time. So, are there any particular time periods that I should visit if I want the chance of seeing several species of human?
Yes, well, there's many. So I think if you hit 3.5 million years ago, you're going to have multiple species of that genus Australopithecus. That's when around, for example, Lucy, who is a very famous fossil of a species that we call Australopithecus afarensis. It's one of the most complete skeleton that we have of a hominin, which is a human ancestor, like ancient relative. So we have several species right around that time. But if you want to have more kind of diversity in terms of the hominins that you see, you want to really hit kind of the end, extreme end of the Neogene. So, I mean, the Neogene ends around 2.58. So that would be a good time to go because you have two very important lineage that emerge kind of right around there or right before there. And one of them you will know because it is the most interesting to all of us, which is ourselves. So our own genus, the genus Homo, emerges right around that time. We think about 2.8 million years ago, as far as we know, the most recent estimates. But around the same time as well, we have another lineage that appears, a lineage that is completely extinct now, that is called the Paranthropus lineage. And they look extremely strange, very different from us. They are hominins, so they are part of our family tree, but they have, really large teeth. We think that they were eating either grasses or tubers, something that is very hard. And they survive for several hundreds of thousands of years, and they are on the landscape at the same time as early members of the genus Homo. And then you still have the Australopithecus that I talked about today, which are the earliest confirmed hominins. There's some late surviving species that are still on the landscape at the same time. So it's definitely those three main lineages, Australopithecus, Paranthropus, and Homo, are there right around the end of the Neogene at the same time, coexisting. Each are an important part of the puzzle of our family tree.
So if I went to the end of the Neogene, you've got not just different species, different lineages, all in Africa. This sounds like I'd be bumping into early hominins left, right and centre wherever I went. But if we're being realistic, what are the chances, do you think, that I will actually see one of these early humans? How abundant are they in the landscape?
Right. This is one of my favorite questions. It's something that as a researcher I'm really interested in because we have several sites. For example, I talked about the earliest hominins being around 4 million years ago. So there's one of these sites called Canopoi, very important site that records some of those early hominins. That reports an abundance of hominins within the entire animal population at about 4%. And 4% is extremely high, but the reasons behind that is because every time a researcher sees a hominin fossil, we're trained to recognize them. We always pick them up, right? We never leave them behind. We bring them to the museum. And really, at the end of the day, and that speaks more about the scientific community than anything, at the end of the day, the fossils that we count are the ones that we bring back to the museum. So it kind of inflates this abundance, and that's true for this one site, but it's true for every site that we study in paleoanthropology because we are so biased in finding those remains. And it's difficult to have a real estimate because even if you think about primates in general, we are also going to pick those up. So it's really hard to estimate what a real abundance would be. But if I had to take kind of an educated guess, I would say it's less than 1% or way less than 1% within the animal population, the chance that we would encounter a hominin. So you would be very lucky, despite the high abundance, you would be very lucky if you bumped into one.
This habitat is their home for them, so they're absolutely at home in it, whereas I'm going to be lumbering through, sweating, tired. So I think they might outsmart me in some cases.
Right. You might want to sit, under a shaded tree or something.
Oh yeah, definitely. Sadly, that's just about all we have time for today. I've had a fantastic time exploring the environments of the Neogene. And now, before the sun sets, I'd like to end by asking both my guests for their one top tip for this period.
Oh man, see, here's the thing. I like to joke that if I had a time machine, I would go see if I was right. I would want to go back to the times that I have studied and just see if I had it right. Yeah, so personally, I would probably go to my field site in Kenya, which could be very dangerous because there was an active volcano in the early Miocene.
All right.
So that's another thing to consider. If you're going to Africa, though, Rift Valley is super active. Common sense, please. But I think that's when I would want to go because I have seen the fossils, both the plant fossils, but also all of the work that's been done on the vertebrates. And, Miocene apes, that's when we're starting to get onto the line that eventually ends up here with people. And I want to know, how did we get here? Early Miocene, East Africa, watch out for volcanoes. That's where I'd go.
And how about you, Laurence?
Yes, and this is going to be a kind of a fun one. So one of the most famous remains that we have from the Neogene is this one site called Laetoli. And this is a site where there was basically a fall of ashes, of volcanic ashes, that cooled down and were kind of wet. So we're kind of mimicking wet sand on the beach. And we have preserved from around 3.9 million years ago ancient footprints of hominids. So there's this species called Australopithecus afarensis, which is the famous Lucy, that's her species, that were walking in those volcanic ashes. So I would want, if I was visiting, right, this time period, I would want to go to Laetoli, which is in Tanzania, and walk along the hominins and other animals that were also there. We also have footprints from them, walk on those volcanic ashes. And they were preserved in deep time, so we have them, still we have a record of those animals being able to walk. And for the hominins, that's specifically important because we know for sure, although we still kind of knew because of their fossils, their anatomy, but we know for sure that they are bipedal, that they were able to walk on two legs, which is something that distinguishes humans from basically everyone else. So that would be a fun spot to go. Should be probably quite pleasant to walk on these ashes, and definitely something you wouldn't want to miss.
All that's left for me to say is thank you very much to my two guests, Dr. Annie Baumgartner and Dr. Laurence de Mouchel, for sharing their Neogene travel tips. If you've enjoyed what we've been talking about today, then make sure to check out their work and their research. There are links in the episode notes. And most of all, thank you to you for listening. I hope you've enjoyed this episode, and if you have, please feel free to like, subscribe, share, and leave a positive review. And I hope you'll join me again for another episode of the Backpacker's Guide to Prehistory. But until then, safe travels.